This shows the comparison of gas dispersion in two tanks. This is the comparison for gas-liquid mixing between two-stage conventional six-bladed flat turbine and a combination of Satake Supermix HS100 impeller and HR100 impeller. Moreover, Satake sparger is applied to HS100 impeller. This is the comparative operations under the conditions that the same impeller diameter are used and the power called P net is same. Gas absorption performance called KLA, it is oxygen transfer capacity coefficient on HS100 and HR100 is increased by about 27% compared with conventional six-bladed flat turbine. In case of two-stage six-bladed flat turbine, air bubbles at backside of the blade are formed, then the shear and flow effect are decreased. For this reason, the size of air bubbles become larger than those of HS100 and HR100, and air bubbles do not disperse inside the entire tank. You can confirm that there are less air bubbles at the tank bottom or between the blades. In case of HS100 and HR100 compared with six-bladed flat turbine, you can confirm that smaller air bubbles disperse inside the entire tank. The size of air bubbles on HS100 becomes smaller and the flow effect is better, so you can confirm that gas holder performance becomes higher. Here we explain the feature of HS100 impeller. As for gas-liquid mixing, it has the superior characteristics dividing liquid fluidization effect and shear fracture effect. Six-bladed flat turbine requires liquid fluidization effect and shear fracture effect simultaneously. If gas ventilating volume is increased, the air bubbles are formed at the backside of the blade, called flooding. And the discharge performance decreases drastically, then liquid fluidization effect drops. Simultaneously, mixing power also drops drastically. On the other hand, HS100 impeller has a small angle of attack at blade part of, and air bubbles are seldom formed at the backside of the blade. Then liquid fluidization effect does not decrease very much, and the decrease of mixing power at ventilating can be restrained. Therefore, it is possible to utilize as much motor power as possible. HS100 impeller utilizes the lifting power by upward flow and downward flow and concentrate the flow to the tip of the blade. Compared with six-bladed flat turbine, the strong shear and gas disperse can be exerted by utilizing the relative speed differences at larger discharge place. Compared with six-bladed flat turbine to be used for gas-liquid mixing conventionally, it can realize the lower power number. It is about 65% decrease, and it can get the higher gas absorption performance, and it improves the liquid fluidization. In case that the liquid depth is in high side, extremely effective liquid fluidization inside the tank and shear fracture effect can be exerted by combining with high discharge radial flow type impeller, HR100 impeller. Combination of Satake Supermix HS100 impeller and HR100 impeller can achieve the effective mixture at gas-liquid mixing. This shows the comparison of prevention of sedimentation in two tanks. This is the case comparing the conventional two-stage four-bladed pitched paddle and Satake Supermix HR320 impeller combined with HR320S impeller regarding slurry mixing. Impellers having almost same diameter are used. This is the comparative operations under the condition that the same impeller diameter are used and the power called P net is same. And same volume of glass beads with specific gravity 2.5 are thrown into the tanks respectively. Observing the flow condition inside the tank from the movement of glass beads as for two-stage four-bladed pitched paddle, glass beads are stagnating at the tank bottom. And you can find out that the flow inside the tank is not stable from the condition that the stagnation volume is changing depending on the time. On the other hand, HL320 impeller has unique shape of the blade in order to realize high discharge flow rate and radial flow pattern. For this reason, there is no stagnation of glass beads at the tank bottom, and the discharge flow goes up along with the tank wall without disturbing the flow from each blade. You can confirm the very large one-loop circulation flow inside the tank. Here we explain the features for HR320. Slurry stagnation at the tank bottom can be solved due to the radial flow pattern. Compared with conventional four-bladed pitcher paddle, it can realize the lower power number by about 65% and higher discharge flow by about 35%. HR320 impeller has excellent discharge performance and can exert the superior mixing performance compared with conventional four-bladed pitcher paddle, not only the case for slurry homogenization but also in various mixing cases.